we look at the symbol here, it's just less than. So that means that we'll have -3 with a round bracket because of that. Okay, and then we're going to have 5. So we go comma 5 on the other side, square bracket, because 5 is inclusive. Okay, 5 is included here. Then we go to our range. These are the y values, right? Remember, domain is x, range is your y. There's only one limit. So y is greater than 2, but not including 2. So that means that 2 is the lowest, and what's the highest? Well, we don't know, right? It's positive, it goes to positive infinity. We know it's going from 2 all the way to infinity. 2 is not included because of the symbol here, and infinity is definitely never included. Okay, you should never have a square bracket around the infinity symbol. Okay, so we've got that. Is this discrete or continuous? And the idea is that it's continuous, right? How do you know it's discrete? You'll see later with an example, right? Because you're saying that everything between these two values is included, so it's continuous. And same here. I'm just going to leave it at continuous like that, right? So everything in between, you can have -3, -2.9, -2.8, anything in between these two values, like 4 would also 4.5, 4.7, everything all the way up to 5 would be included, right? So it's continuous. So how would you graph this? How would you represent this in a graph? And right now we're just gonna make a sketch, right? Approximately. So my x values, notice what I'm going to do here. I'm going to go from -3 here. This is my -3x all the way to 5. I'm just marking it along the x-axis, okay? And then you go to your y-axis and you go to 2. Let's make this 2. And it just goes up to infinity, right? So how could you translate this to a graph? Okay. And the answer would be, I just made this up this morning. Would this make sense? Could you make infinity? Because you need this to be contained. If you drew a line from -3, but it would have to start up here somewhere, right? Because 2 is included. You go from here straight through there, and then it would have to go up, right? Because then you're going from -3 to 5, but 5 is included, right? 5 is included, so that's the solid line will take care of that. -3 is not included, so I'm going to put a big circle here at -3. Sorry, that's my bad. It should be a hollow point there. So this is -3, and our y value is at 2, and then it goes up from there. So this would be a graph that would satisfy your domain and range. Okay. Is this a function? Would this be a function? If you do the vertical line test right here, you'd fail, right? Because it would cross it all along here. So this would not be a function. Not a function. Because of this. You could do the vertical line test all along, but then here you would have an issue, okay? So there's that. not a function. Okay. Now, yeah, I see the mistake, folks. This, if this is not included here, but there's a solid line going through 2, then 2 has to be included. So let's fix that. Just do this. That's what I had issues with. Just put an equal there for this. So then this should be a square bracket here, right? There it is. That makes more sense. Because of this solid line going from end to end, right, indicates that 2, the y value 2 is included. Okay, so that could not have been. So now let's do a different one here. This one. Copy this into the interval column, okay? You have your domain and range again. I leave some space in between. So you have your domain and range, and you write down those 2 there. So writing this down in our booklets. I don't know if at home if you caught that. Oh, sorry folks, this can't be. This is supposed to be a round bracket. You can never have a square bracket around an infinity. So make sure this is a round bracket, right, by the negative infinity here. Change that, please. All right. So negative infinity to positive infinity, that means this is x belongs to the real numbers. It's telling you that all the real numbers are acceptable. Okay. That's how you translate that. Okay. And then negative infinity to 3, right? That means that for your y values, you're coming from negative infinity and you go all the way up to 3 inclusive. So that means that y will be less than or equal to 3. Okay? Y is less than or equal to 3. And both of these are continuous. And how would you graph this? Well, there are a number of ways you could do this, but if you make this 3 up here, if this is y equals to 3, you could do a V shape that spreads out like this. Okay? Because this tells you that, right, the x goes from negative infinity to positive infinity because this will open up indefinitely to, right, the negative x and the positive x. So that's why this is there. And then for the range, you're going to negative infinity, which is true, right? We're going to negative infinity all the way up to 3. Okay, so this graph would satisfy that particular scenario. Okay. And then the last one, just try your best. Basically what I did is a grid, and I went 1, 2, 3 in each direction. I went 3 in each direction, and then I just plotted those points. Try to put them as close as possible to where they're supposed to be. So you're getting a graph and now you're supposed to fill in the rest. And I'm handing back the cumulative tests or exams. So if you are coming by here, if you're not here now, but you're coming in tomorrow at some point, just drop by and ask for it if you want it before your next scheduled date. So these two are lining up here, just so you know, and these two are also lining up. That's kind of like the end goal here. And then we're gonna kind of trace all the way, and we're gonna have a domain row and a range row, right? Moving to the left of this, we could tell clearly that this is discrete, right? Because we have points plotted. So it's discrete for both of them. Okay. And when it's discrete, you don't have interval notations. It's not applicable. Okay. Then you have to go to set, because interval, you can only have endpoints, right? You can just have start to end. You're assuming that everything in between is also acceptable, and that's not the case. Okay. Only whole values can be included in this case. So we go to domain, and you go from lowest to highest. Do not repeat. Okay. Lowest to highest. No repeats. Okay. That's important. So for domain, we go from -2, -1. It happens twice, right? But that's it, -1. Then we go to 2 and 3. Done, right? So 2 and 3. That's for our input, our domain, our x values, and then we go to range. We go from the smallest, which is -3. Then we have one at -1 up here. And we have one at +1. And then we have one at 3, right? There are two entries, but we don't repeat it. Okay, that's it. Is this a function? No, right? It's not a function because of this. It's okay here. This is okay, but this is not a function. Does not pass the vertical line test. Okay. Okay. So we're gonna go back, continue in our booklets. We're we're gonna continue. So today, I was going to do this yesterday, but I guess it never happened. That's okay. So we're gonna go to this page. So find this in your booklets. So we're gonna learn how to read graphs. Some of you are already pretty good at it, but we're also gonna introduce some terminology here. Okay. Interpreting and sketching graphs. Describe a possible situation for the graph. The properties of a graph can provide information about a given situation. So the important thing here is to always look at a graph and see what's happening, not just getting numbers, okay? What is happening here? So you can tell that along the x-axis, this is our x-axis here, right? And that one is called the independent variable. So the x is the independent variable. I'm sure you remember, you may have heard of that. So we call this the independent variable, also referred to as the horizontal axis, also known as the x-axis. So all three belong to the x-axis, right? You can call them, we know that the independent variable goes along the x-axis. We can call that the horizontal axis and just the x-axis, which is probably what you're most familiar with. This one here, the y, right? This is called the dependent variable. Okay. It's also referred to as the vertical axis and also just the y-axis. Okay. We can put that one in brackets like that. Notice that when you graph, I'll just make this note. When graphing, right, you need to label axes, right? You need to have an appropriate scale. Okay. And it's supposed to be consistent. That's the key with the scale. It's supposed to be consistent. So if every box is 5 for you, then you need to stay with that. You can't just say start at 10 and then go up by 5. It doesn't work. Okay. I will also tell you, and I will highlight them, we are really keen on in this course, there are 2 points right here. We call those the intercepts, but specifically this one is called, I'll just put an arrow to this one, that's the y-intercept. And this one over here is called, it becomes a bigger deal later on, but I already want you to start hearing the terms. This is called the x-intercept. So it's basically where the line intercepts the x-axis, and here is where the line intercepts the y-axis. We call them the y-intercept and the x-intercept. Okay. In particular, this point right here is 14, 0, right? So when x is 14, the y value is 0. It's right on the x-axis. In particular, this point over here is when x is equal to 0, when y is equal to 5. Just by looking at this graph, this is 5 right here. So it's 0, 5, and 14, 0. And you notice that the zeros are always there. Here, x is equal to 0, and over here, the y is equal to 0. Okay, so those are very important to us here. They will mean something. Okay, so some terms when you want to describe a line, right? This would be a steep increase here. This would be a steep decrease because you're going down from left to right. You always read a graph just like you read a book, left to right. So it's an increase, decrease. There's no change when it's a flat line. There's a moderate increase. Then there's a steep decrease. And then we're back to a moderate decrease. So that's kind of like how we would describe the different sections in this particular situation, this scenario. Okay, so we will continue. A lot of stuff, a lot of terms there, I know, but here we go. Each point on this graph represents a person. That's important there. So you have the title, wages and years worked. Here we have hourly wage. This is your y-axis and this is your x-axis, right? Always keep that in mind. That's still there, but now we have a context. A context means it's not just random values or abstract values. They're attached to a unit, right? There's a unit in place and there's number of years worked and hourly wages in dollars, right? So which person has the greatest hourly wage and what is the wage? So the greatest hourly wage would be person F. Person F. The wage is, and then we just read the graph, right? $12 an hour. $12 per hour. Which person worked for the least number of years, and what is the number? So now you want the smallest number of years, right? So you go all the way down here, and it's A, person A, right? Worked for 1 year. That's this one right here. Okay, the smallest number of years. And I just want to mention, what is this, the zipper we call them, right? It's just what do we call it? Data break. So it's just saying like omit everything between 0 and 8 along the y-axis. Let's just start at 8. You can do that, but I would not recommend that. Sometimes it's called misleading. It's misleading the graph. So we use the example here, but I would stay away from that. Also, this is also, remember, it's still the domain, and this is still the range of this graph. Okay, always in the back of your head, you're like, yeah, this is my domain, and this is the range. Okay. Which two people have the same hourly wage, and what is the wage? And you can tell that B and D, right? Person B and D. They both earn $10 an hour. I think so far you're all like, yeah, I got this, right? It's pretty straightforward. Which two people have worked for the same number of years, and what is that number? So now you want to see, right, number of years, where is there an overlap? And there's, sorry, did I get that earlier, right? B and D, yes, okay. So number of years, right, people, a person C and D, they both worked for 3 years. Oh, sorry, I don't want to use up that E spot there. They both worked for 3 years. Is this relation a function? You check, you do the vertical line test, and you know that this makes it fail, right? Nope. The same x value and that would be 3 years, is pointing to two different y values. The same x value, which is 3 years, is pointing to two different y values. So it disqualifies it right there. Okay. I could ask you for the domain and range of this as well. That shouldn't be an issue. Let's keep going to the next page here. Zoom out a little bit. Describing a possible situation for a graph. And this graph, if you look at it, right, is just read the labels, right? Distance from home and time in minutes, right? So this will tell you the distance from home to Troy's home specifically over time, okay? How Troy's distance from home, sometimes it's just stating the obvious, changes over time. That's what you can put down there. And when I ask you to describe a graph, you want to pick a section. So meaning, as long as it's going the same direction, right, we consider this one segment. And when it breaks and changes directions, then you have a new segment formed, right? So we will take one segment at a time and break it down and describe it, okay? So segment O to A, so from 0 to A, the graph goes up to the right. So the distance from home is increasing. So obviously Troy is probably starting his walk and walking away from home, right? So it's increasing until there's a change now. So from A to B, so from point A to B, the graph goes down to the right. So the distance from home is decreasing. So I don't know if you want to do this. If it's going up from left to right, you have something, the graph is increasing. And if you have something going down from left to right, we know that it is decreasing, okay? Then from B to C, the graph is unchanged, right? It was horizontal. So the distance from home stays the same. Okay. And then we'll fill in this side here. C to D, the graph goes down to the right. So the distance from home is decreasing. Okay. And now we're going to describe it in more detail. Okay. So we're going to look into how does it change along the y-axis and how does it change along the x-axis. Okay. So we almost want to like focus on this, right? So Troy, how could we say Troy hikes away from home for 3 kilometers over 20, this would be 25 if you think about it, right? You can tell that the scale is 5, every box is worth 5. And then so it's over 25 minutes. Troy hikes away from home for 3 kilometers over 25 minutes. So we looked at how did it change along the y-axis and how did it change along the x-axis. So we make specific reference to that. How exactly you write it, that's up to you. Then our next point is here, right? So here you want to focus on what changed here, right? So from A to B, you actually traveled another kilometer, right? Over a certain time frame. So from 25 to 40, that'd be 15, right? 15 minutes. So Troy hikes towards home for 1 kilometer over 15 minutes. So because the distance from home is decreasing, right, it's assumed that he's walking towards home, right? And then what happens here? He's probably resting, right? Troy stops. Troy takes a break for 5 minutes. And then the last one would be Troy walks towards home for, in this case, if you look at, right, you're starting at 2 and you're going back to 0, right? So for 2 kilometers over, how long did it take? Well, you kind of look at 45 and 60, subtract those, right? You get 15 minutes. So you're looking at how does something change from one point to the other in terms of your y and in terms of your x, right? And then you bring it down into the story here. Sketching a graph from for a given situation. So now we're going to be basically told a story like this, and we're going to translate that into a graph. We're going to go backwards the other way. Okay. So here it is. At the beginning of the race, Alicia took 1 second. I'm going to highlight the important information, right? It took 1 second to reach a speed of 3 meters per second. Then 1 second to reach a speed of 8 meters per second. She ran at approximately 8 meters per second for 12 seconds, then slowed down to a stop, right? In 2 seconds. Sketch a graph of speed as a function of time. And this is actually important. Speed as a function of time. Label each section on your graph and explain what it represents. Okay. So first of all, you need to know what's going to go along the x-axis and what's going to go along the y-axis, right? And this kind of gives it away. You want speed as a function of time. So that would be s as a function of time. Remember f of x, right? F of x, that's a function. So we're just now using s, right? Speed in terms of time, that's what you're saying. And we know that this is the x value. And that this, the speed, is the y. Okay. So this goes, so you'll have time, and it's in seconds, of course, along the x-axis because of that. you determined the independent is always inside the bracket, right? It's like your x, so that goes along here. And so speed, you got to label it in speed, and you got to also give me the units. Okay, so what is the speed measured in? It's meters per second. So you're going to go meters per second in brackets like that. So label and unit. Okay, label and unit. Okay, so we can say that, right? We have a start here and a start there. This is like our 0 going for both. And we're gonna have to try to figure out what is our scale going to be here. And when I look at my speed, the highest I go to is 8 meters per second, right? That seems to be the highest number. So I'm gonna go 10. I'm gonna go at least up to 10, right? So can I use a scale of 1? So, right, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh yeah, absolutely. You can tell already, right? But I'm only going to mark every second one to save some time here. Right, so you go 2, 4, 6, 8, 10, 12, and that's more than enough. So your scale is 1, but you're only labeling every other one. You could also label every fifth one if you'd like. Right? Okay, and then over here, time. We have to see how this pans out, right? Because it took 1 second to reach a speed of 3, and then another second, so that's 2 seconds. And then you spend another 12 seconds at that, and it took you another 2 to get to a stop. So 1 and 1 is 2, plus 12, that's 14, plus 2, that's 16. So you need to account for 16 down here. So let's see, 2, 4, 6, 8, 10, 12, 14, 16. It works out perfectly. So I'm going to mark every other one. And if you don't get this, just start graphing, and you're going to find out, oh, I don't have enough. I need to increase or change my scale to make this graph fit. Okay. So let me just have that there. So it took 1 second to reach a speed of 3 meters per second. This, folks, will give me my first point right here. Okay. This is a point. This will get you your point, your first point. Right? So it took 1 second to get to 3. So we put that point right there. Let's call it the same. Let's give it the same letters as before. So we're going to call this O. Then we're going to call this A. That point right there is going to be our A. And then it took 1 second to reach 8 meters per second. So you move over 1 second and then go all the way to 8. That'll be your second point there. Then we'll go, she ran 8 meters per second for 12 seconds. Okay, so you're staying at that speed for 12 seconds. So if you start at 2 and you add another 12, that gets you to 14 right here. That's C. And then it took 2 seconds to come to a stop. So this would be D right here. I think I'm just looking at my notes here. If you want a title here, Alicia's speed over time. Okay. Before you go ahead and connect your dots, okay? Can we connect the dots? Is it possible to do that? And the answer is, let's see, time, right? Time, you can have fractions of seconds, right? Like you can have decimals of a second. So this is continuous. We'll just make a note of that. It's continuous. Speed, you can definitely have anything in between, right? If you have a digital speedometer, like some of you have what are those Honda Civics or whatever? I don't know. There's a car, or maybe more than one car already that has a digital, right? You can go decimals, right? Uh, that's possible. So this is also continuous. That's just in bracket. I don't need you to put that down ever for a graph. It's just for you to know now. So you can connect. You can connect the dots, okay? So we're going to go ahead and connect because anything in between is possible. There. So we've connected. This story is now here, right? And maybe I'll just add a note here how I determined this, right? X scale, right? I went 1 second plus another, this second plus another second plus 12 plus 2. That gave me 16. That's how I came up with that, right? Because things are changing as you go along the x-axis. Time is accumulating, right, over time. So from O to A, now let's describe this section here because it's steeper here than here, right? You can clearly tell. So O to A, speeding up to 3 meters per second for 1 second. And then A to B, we're speeding up by, how much are we speeding up by? If you go from 3 to 8, you sped up by 5 meters per second. Over 1 second. It took you 1 second, like if you look along the x-axis, to go from 3 to 8. Okay, so 5 meters per second there. And then we're going to go from B to C, kept constant speed for 12 seconds, right? There was no speed increase here, so nothing changed, right? So you kept your constant speed. You can also say the speed did not change for 12 seconds, okay? And then from C to D, slows down to a stop. You could also say slows down by 8 meters per second, right? Over 2 seconds. So we basically said the same thing that we were told, but in a slightly different way, just looking at how much did it change over time. Okay, I'll make a note here. Maybe I'll do it on the back side because it's a blank page there. Um, Let me see here. Should I start? I think that'd be a good idea to label the points. Okay, so can you just write down this is 0, 0. This one is 1, 3. This point right here. This point right here is 2, 8. This point right here is 14, 8. And this point right here is 16, 0. point D. It's good to start labeling your graphs, okay? And notice what I want you to catch from this. 3 meters per second for 1 second. If you go 3 minus 0, you get the 3, right? 1 minus 0, you get the 1 second. Now focus between A to B. 8 minus 3, that's 5 meters per second, right? Your y changed by 5 and your x changed by 1. You can tell that as well. And then from B to C, right, constant speed, like if you look at 8 minus 8 would be 0, right? There was 0 change in your y. 14 minus 2, that gives you the 12 seconds. So you can, that's what I want you to start seeing. That's really what's happening in the background here. I want you to take some time, and what we're going to do here is we're going to do the same thing here. We're going to go O, A, B, C, and D. This is on the next page, right? You should have that. So you always start with O as your starting origin, right? And then you go A. So every time it's bending or kinking or whatever, you add a letter E, F, G, and this is H. And just assume that everything is just 1. Okay, all the scale everywhere is 1. And I want you to describe every section, right? Just like we have been doing so far. And this is the good part here. If you want to use this blank page right next to it to do that, you have tons of room, right? Maybe just call it graph A and B so you have a reference on the side, and then go ahead and do that. I'll give you a little bit of time to do that right now just to practice that skill, and then I'll go over it before assigning some homework. Okay, so pause it here. All right, I'm going to go over these two tomorrow, so finish those up please, and then I want you to go through page 281 3 to 9. They're not very long, but they go through this. And this is graphing, folks. 286, 1A and 2A. Only do the A's, okay? Use the grids that are provided here. Like below this, there are 2 grids there. You can use those to graph. You're gonna have to be careful with your scales, okay? Because those numbers get a bit big. So you might have to go up by 50 or by 100 or whatever. It works, okay? And I'll go over that as well tomorrow.